In this video, we are going to look at how we can determine the shape of molecular compounds. So the shapes of molecular compounds are going to be determined by the electron groups around the central atom, and that includes both bonding and pairs of non-bonding electrons around that central atom. So when I say a group of bonding electrons, that would be a single bond would be a group, or a double bond would be a group, or even a triple bond would be a group. And then non-bonding electrons would be a pair of electrons would be a group of non-bonding electrons. We look at how many groups of those are around the central atom, because each of those groups are going to try and get as far away from each of the other groups as possible. And so that determines the shape of the overall molecule. Let's look at a few examples and a few shapes. The first shape we're going to look at is linear. And linear compounds are going to have two groups of electrons around that central atom. Those two groups are going to try and get as far away from each other as possible. So that ends up being 180 degrees, which is a linear shape. Here we have a carbon dioxide molecule, and the carbon dioxide molecule has a central carbon atom. So you look at your central atom, and then you look at the groups of electrons around it. So you have a group here, that's one double bond, and you have a group over here. So we have two groups of electrons around our central atom. Those are getting as far away from each other as possible. It's 180 degrees. So carbon dioxide is a linear molecule. Here is a 3D depiction of what carbon dioxide would look like. The next shape we're going to look at is trigonal planar. For trigonal planar molecules, they are going to have three bonding groups around the central atom with no non-bonding electrons. And so here is our central atom of carbon, and you have a group up here, a double bond, a single bond between the carbon and hydrogen, another single bond. So you have three groups of electrons. They get as far away from each other as possible. Ends up being 120 degrees. And so that's the trigonal part, is that it looks like a triangle. Planar is that it is flat. It is on a single plane. Here is a space filling, or a model of what that looks like. And then I've turned the model. The blue is the central carbon, the red is the oxygen, and the white are the hydrogens. And so you can see that it's on those hydrogens and hydrogens and oxygen are all on the same plane, which is why it's a trigonal planar molecule. Our next shape to look at is tetrahedral. In tetrahedral molecules, you have four bonds around that central atom. So here is an example. We have carbon tetrachloride, where around our central carbon atom, you have four single bonds. So that is four groups of electrons. Those four groups of electrons are trying to get as far away from each other as possible. And so they, in three-dimensional space, point towards the corners of a regular tetrahedron, which is why it's called tetrahedral. So this molecule is not planar. It does not look like what just the typed out version of it looks like. Here is a three-dimensional model of what that looks like, and so you can see the green atoms of chlorine would be at the corners of a regular tetrahedron. Remember, that would be like a pyramid with a triangular base. A trigonal pyramidal molecule is going to have three bonding groups and one non-bonding electron pair around the central atom. In our example molecule here of ammonia, this nitrogen, it's not shown, I'll draw them in. Let's see, pair of electrons on top of the nitrogen. And so that is a group of electrons. So you have actually four groups of electrons around the nitrogen, three bonding, and this non-bonding pair of electrons. So that's four groups. Those four groups of electrons will have a tetrahedral arrangement. But as far as the shape goes, we look at the atoms, and so the atoms end up with a pyramidal shape. So this is called trigonal pyramidal, where the blue nitrogen up here has, I'm going to kind of draw it like this, has those non-bonding electrons are taking up space, but they don't show up in the overall shape of the molecule, but it does push these 3 bonds down further. So it is not planar, like just having 3 bonds around the central atom with no non-bonding pair. So that non-bonding pair of electrons pushes those bonds down a bit, and it becomes trigonal pyramidal. Here is our next one is bent. And bent molecules, you are going to have 2 bonding electrons pairs around the central atom, and then 1 or 2 non-bonding electron pairs. For our example of water, they have 2 pairs of non-bonding electrons. They take up space, and then 2 single bonds around it. So you have 4 groups of electrons. Those electrons have a tetrahedral arrangement, but the molecule itself has a bent arrangement because the non-bonding electron pairs take up space and push those other bonds down, and so it ends up with a bent shape.